Welcome back, students. We'll be looking at section 4.4, terminology for applications of linear systems. Step 1, read the problem slowly and carefully. Notice what information is provided and what the problem asks you to find. Step 2, assign variables to represent the unknown values. Depending on the problem, a diagram, drawing, or table is extremely helpful for designating what each variable represents and organizing the information. I cannot emphasize that enough. Having a diagram, a drawing, or a table is very, very helpful. It just organizes your information for you and makes it easier for you to figure out how to set up your problem. Step 3, write 2 equations with both variables from the diagram, drawing, or the table. Step 4, solve the system of equations using the substitution or, that word is important, the word or elimination method. The method chosen is up to you. Either method will work. Step 5, check your answer and verify that the values found work in both original equations. So we're going to be focusing on word problems in this section. Step 1 in this first problem, read carefully. 2 of the longest running shows on Broadway are The Phantom of the Opera and The Lion King. There have been a total of 19,272 performances of the 2 shows, with 4,066 more performances of The Phantom of the Opera than The Lion King. How many performances were there of each show? All right, so the first thing I notice is that we have a total amount, and then we have 2 things that we're comparing. We have The Phantom of the Opera and we have The Lion King. I'm going to designate Phantom of the Opera as P. I'm just going to write P up here. And then Lion King is going to be K. I'm going to have K here. Now we need to go back to our problem and read again to figure out how we need to figure in or how we need to fill in the blanks of what they are equal to. Okay. So it said with 4,066 more performances of The Phantom of the Opera than The Lion King. The way they describe Phantom of the Opera is by referencing Lion King. So Lion King is our standard that we're working from, okay? So Lion King, I'm going to just have K here. So the Lion King equals K. Now we need to figure out how to write Phantom of the Opera. It said with 4,066 more performances of The Phantom of the Opera than The Lion King. All right, so K, and then we're going to add an additional 4,066 to that so that it will equal what the Phantom of the Opera actually was, because it said Phantom of the Opera had that many more than Lion King. So we have our 2 pieces now. Step 3 says write 2 equations using both variables. All right. So to find the total, you would add the 2 shows together to get the total, right? You would have P plus K equals that 19,272. Well, then it said that Phantom of the Opera, P equals K plus 4,066. These are our 2 equations that we're going to use. Now, in the previous steps, in step 4 above, when I read through them, it said that you could use either substitution or elimination. It's up to you. I'm going to use substitution in this one because it makes the most sense. We already have one of the variables isolated in our 2 equations. But again, you can choose either. But I'm going to write my 2 equations over here. So we have P equals K plus 4,066. And we have P plus K equals that 19,272. I'm going to take that equation, P plus K equals 19,272. I'm going to replace my P with what the P equals. The K plus 4,066. Keep my other K that was in the problem already and just rewrite out the rest. So I substituted in what my P was here. So I'm going to get 2K plus 4,066 equals 19,272. Subtract that 4,066. I get 2K plus 0 equals, see, it's going to be 15,206. Rewrite that. Divide both sides by 2. And I get K equals 7,603. So we now know that the Lion King sold 7,603 tickets, but we still need to figure out the Phantom of the Opera. So I'm going to take the other equation, the P equals K plus 4,066, and I'm going to replace my K because I now know that value. So P equals 7,603 plus that 4,066, and I get P equals 11,669. All right, so now we need to double check and make sure that we did in fact get our correct answers. So I'm gonna come over here, P plus K equals 19,272. Replace both my values in here, 11,669 plus 7,603. And I do in fact get 19,272. So we did do the problem correctly, all right? Next example. For a production of Les Mis, main floor tickets cost $127 and rear mezzanine tickets cost $97. Club members spent a total of $3,150 for 30 tickets. How many tickets of each kind did they buy? All right, so the first thing is we have a different type of problem. So I'm going to create a chart to fill in, which you already have here. And we're going to work on filling in the different pieces of this chart. So the first thing I want to do is designate a variable for each of these items, the main floor and the mezzanine. I'm going to designate the main floor as X. I'm going to make the mezzanine Y. All right, so I know that when I add the number of tickets from the main floor to the number of tickets from the mezzanine, I get a total of what they told us. We get 30 tickets. So my total of number of tickets is 30 here. Now let's talk about filling in the price of the ticket. They told us the main floor costs $127. So I'm going to put that here. They also told us the mezzanine costs $97. But they don't give us the total cost price per ticket. We don't actually need that for this particular problem. Now we look at total value. I want you to notice up here, this little key. It says column 1 times column 2 equals column 3. So the way we get column 3 is by multiplying column 1 and column 2 here. So X times 127 is going to be 127X. 97 times Y is 97Y. And then we get our total value of dollars, which they actually gave us. So we don't have to do that multiplication. They said it was 3,150. Okay. All right, so this is where we get step 3, writing our two equations using both variables. Our first equation is this column right here. It's going to be X plus Y equals 30. Our second equation comes from this column right here. It's going to be 127X plus 97Y equals 3,150. okay? Now I'm going to take those two equations and find my values for x and y. I'm going to bring them over here to the side and rewrite them. So x plus y equals 30. And then I have 127x plus 97y equals 3,150. All right, so the first thing I've got to decide is, do I want to use substitution or elimination? I'm going to use substitution for this one just because I notice I have x and y singles and I can isolate one of them fairly easily. So I'm going to rewrite that here. X plus y equals 30. And I'm going to isolate the y. I'm going to move the x. So subtract x. So my new version of that equation is y equals negative x plus 30. I'm going to use this in the other equation. I'm going to use substitution. So I'm going to write 127x plus 97 times what my y value is, which is that negative x plus 30 equals 3,150. Go ahead and distribute. So I end up with 127x plus a negative 97x plus, let's see, 97 times 30 is going to be 2,910, and then equals the 3,150. All right, 127x plus a negative 97x is going to give us a 30x. Subtract my 2,910 from both sides. I get 30x plus 0 equals 240. Divide both sides by 30. And I get x equals 8. So I now know my x value. So I'm going to go ahead and divide this section off so we can find our y value. So I'm going to take that other equation, the x plus y equals 30. Replace my x value with the 8 that I found. Subtract 8 from both sides. And I get y equals 22. Now we just need to check it. All right, I'm going to plug it in the 127 equation. So 127 times 8 plus 97 times 22 equals that 3,150. So 127 times 8 is 1,016. 97 times 22 is 2,134. And then rewrite this side. All right, so 1,016 plus 2,134 is 3,150. So we do, in fact, equal, and our answer is correct. All right, what about solving a mixture problem involving percent? We're going to follow the same steps as far as read carefully, fill in our table, write our equations, use either substitution or elimination to find our values, and then check your answer. But let's see how we fill in our table, all right? So a pharmacist needs 100 liters of 50% alcohol solution. She has 30% alcohol solution and an 80% alcohol solution, which she can mix. How many liters of each will be required to make the 100 liters of a 50% alcohol solution? It's a lot of numbers in there. So this is why I say read carefully and go back and reread it again multiple times until you understand exactly what you have and what they're looking for. All right, so let's fill in our table here. The first thing we need to do is designate variables for each of these items. And the two items that are being compared is the 30% alcohol solution and the 80% alcohol solution. These are the two that are being compared. So I'm going to designate these as X and y. Now they gave us a total. They said that we need like 100 liters. So here's the 100 liters. And we're trying to figure out how much of each we need to create that 100 liters mixture. Now we need to put our percents as a decimal. So our first one becomes 0.30. So remember, we had to move this percent 2 times to the left to get our decimal. Our next one is going to be 0.80. And then in our last box, we're putting what we are trying to create, which is a 50% alcohol solution. Because it says a pharmacist needs 100 liters of 50% alcohol solution. That's what they're trying to make. So we're going to have the 0.5 here. We're going to go ahead and turn it into a decimal. Now remember, how we get our third column is by multiplying the first 2 columns against each other. So right here, I'm going to have 0.30x. The next one is 0.80y. And then 100 times 0.50 is going to give us 50. We now have our 2 columns that we needed to make our 2 equations. So let's go ahead and write those over here. We have x plus y equals 100. And then we had the 0.30x plus 0.80y equals 50. These are the 2 equations we're going to use. All right, step 4, let's go ahead and rewrite our equations over here so we can figure out how we want to use them. The first thing I noticed is I have a single x and a single y in that first equation. So I'm going to opt for substitution and by isolating one of those variables. It doesn't matter if I isolate the x or the y. I'm just going to choose to isolate the x this time. So x plus y equals 100. Subtract the y. I get x plus 0 equals negative y plus 100. And that gives me x equals negative y plus 100. This is what we will use when we substitute in. All right, I'm going to take my second equation that I found, rewrite it. All right, one thing that I noticed is the 0.30. I can actually simplify that down to just 0.3. The 0 is not necessary at the end there. I can do the same thing to the 0.80. All right, now I want to figure out, before I do substitution, I want to get rid of my decimals. So I'm going to multiply everything by 10 because we have the 10th place value here. All right, so I end up with 3x plus 8y equals 500. That's a lot easier to work with than a decimal, right? So now I'm going to work on substituting in. I have 3 times that negative y plus 100 plus 8y equals 500. We end up with negative 3y plus 300 plus 8y equals 500. Combine like terms. I get 5y plus 300 equals 500. Subtract that 300. And I get, let's see here, 5y plus 0 equals 200. I'm going to bring that up over here and just finish that out. So let's see, 5y equals 200. Divide both sides by 5, and I get y equals 40. All right, so now I need to find my other value. So I'm just going to create a little box here. So x plus y equals 100. Plug in my y value, x plus 40. Subtract 40 from both sides. I get x plus 0 equals 60. So I end up with x equals 60. These are my two values. I'm going to take my other equation to check my answer. So I have 0.3 times 60 plus 0.8 times 40 equals 50. All right, so 0.3 times 60 gives me 18. 0.8 times 40 gives me 32. And 18 plus 32 is 50. So we are, in fact, correct with our answer. All right, solving problems about distance, rate, which is speed, and time. So we're going to have a little bit of a different chart here, you'll notice. And we're going to have different terms, of course. So let's read carefully. Two cars that were 450 miles apart traveled toward each other. They met after 5 hours. If one car traveled twice as fast as the other, oh, that's interesting. If one car traveled twice as fast as the other, what were their rates? All right, so first thing I need to do is designate a variable for fastest car and slowest car, okay? Because one was faster than the other, and that's how we're gonna kind of differentiate between the two. So I'm gonna label the fastest car X and the slowest car Y. Now we need to fill in time. Well, it told us that they met after 5 hours. So they both were driving 5 hours. So I'm gonna put 5 in here. But how far did they go? Well, we don't really know. We know that they, there was a distance of 450 miles in between them. They're that many miles apart, but we don't know how many miles they traveled before they met each other. So we're going to just do our formula to find distance. So the way we find distance is rate times time gives us distance, okay? So we're gonna have x times 5. So we put in 5x here, and we're gonna put 5y here because we're gonna multiply those first two columns to get that third column. All right, so let's write our equations. I know that we don't know exactly how far each of them traveled, but if we add their distance together, we get that total amount between them, which was the 450. So that's why we're going to set this one up like this. Now our second equation is going to come back from what we read, where it says one car traveled twice as fast as the other car. I have designated the fastest car as X. And X was twice the speed of the slow car. So I'm going to put twice the slow car, so 2y. These are our two equations. Now looking at this, it looks like substitution is going to be the easiest way to go this time because we already have a variable isolated. So that's what I'm going to do. So I'm going to rewrite here and put 2y in for my x. I'm going to say 10y plus 5y equals 450. Combine like terms. I get 15y equals 450. Divide both sides by 15. And I get y equals 30. Now I need to use my other equation to find my x. So x was equals 2y. So I'm going to replace my y. And I get x was 60. Now let's double check, okay? So I have 5 times 60 plus 5 times 30 equals 450. 5 times 60 is 300. 5 times 30 is 150. And those two numbers together do in fact equal 450. So we have done our problem correctly. All right, let's look at our last example here. We're going to be dealing with rate and time equaling distance again, but this time we're going to be dealing with a plane. So it says, read carefully, a plane flies 560 miles in 1.75 hour in 1.75 hours traveling with the wind. The return trip against the same wind takes the plane 2 hours. Find the rate or the speed, basically, of the plane and the wind speed. All right, so we know that the plane flies this many miles in this amount of time. And the return trip against the same wind takes the plane 2 hours. So they're traveling the same distance, but it takes them longer on the return trip because they're flying into the wind. The wind is slowing them down, basically. Find the rate of the plane and the wind speed. All right, so we need to designate variables. This one's going to be a little bit different, though. I'm going to designate that X represents the plane and Y represents the wind current. So when that plane is flying with the wind, so X plus Y, because both are affecting the speed. There's the plane that has the engine giving it its speed, but also the wind that it's flying with that's helping it to go even faster. So we have to put both in here to acknowledge that that is affecting the rate of that plane. Both items are. If it's going against the wind, it's slowing it down. So on this one, we're going to put X minus Y because it's slowing its speed. It's taking away from its speed. Now, the amount of time they gave us for with the wind was 1.75. When it was going against the wind, it took it 2 hours. The distance they gave us, they said that in both times it traveled 560 miles. So now let's put together our two equations, okay? So we have 1.75 times that X plus Y. And that's what gives us that 560. So again, we're using this up here. The rate times the time gives us that distance. That's why I have it set up the way I do. Let's write our other one. We have 2 times X minus Y equals 560. Okay, so I'm going to rewrite them over here. 1.75 times X plus Y equals 560. And then I have 2 times X minus Y equals 560. All right, before I decide what I want to do with these, the first thing I'm going to do is go ahead and distribute. So I'm just going to draw an arrow over here. And we're going to distribute both of these. So I end up with 1.75x plus 1.75y equals 560. I end up with 2x minus 2y equals 560. All right, this one, I think elimination is going to be the simplest way to solve it because trying to isolate a variable would probably give us fractions. We already have decimals. I don't want to deal with fractions too on top of that. So let's see, which one can I get rid of? I think I'm going to get rid of my y's. Let's go for our x first, okay? So I'm going to figure out what I need to multiply these by so that we can get a matching number. If I multiply the top one by 8 and the second one by 7, I think I can get a matching y here. All right, so 8 times that 1.75 gives us 14x. 8 times the other one is going to give us a plus 14y. And then 8 times that 560 is 4,480. 7 times that 2x is going to give us 14x. And then we get negative 14y when we multiply it. And 7 times 560 is 3,920. Add these together, I get 28x. My y's cancel out and become 0. And then I end up with, let's see here, 8,400 when I add those two together. So 28x equals 8,400 Divide by 28 on both sides, and I get x equals 300. All right, so I know my x now. I'm going to use one of the original equations to find my y. So let's draw a line here. I'm going to use the 2 times the x minus y because we don't have any decimals in that one. So we end up with 2x minus 2y equals 560. And I'm going to plug in for my x. 2 times 300. And it was 600 minus 2y equals 560. Subtract 600 from both sides. I get 0 minus 2y equals a negative 40. So negative 2y equals negative 40. Divide both sides by a negative 2. And I get y equals 20. So my wind was blowing at 20 miles per hour. All right, so we're going to check our values. We're going to plug them in to both equations and just see if they work. Let me draw a little line here so we don't get confused. So I have 1.75 times 300 plus 1.75 times 20 equals 560. 1.75 times 300 is 525. 1.75 times 20 is 35. And they do, in fact, equal. So we're good so far. Let's check the other one. 2x minus 2. Oh, let me start over with that. 2 times 300 minus 2 times 20. That's 600 minus 40. And we do, in fact, equal. So that one is also correct. Let's look at our verse. I will lead the blind by ways they have not known. Along unfamiliar paths I will guide them. I will turn the darkness into light before them and make the rough places smooth. Isaiah 42:16. I know for a lot of students, word problems would be considered a rough place. But don't forget, God is with you. I'm here to help you, and you'll be just fine. All right, guys, I hope you're having a great week, and I'll see you in the next video. Bye.